The dashboard said everything was green, every panel. Latency within normal range. Error rate below threshold. Throughput steady, no alerts, but Slack told a different story. Users can't load dashboards. Pages are timing out. Is anyone seeing this? We refreshed Grafana again, still green. That was the problem. Environment context. We were running on AWS. The application stack was deployed on Kubernetes through EKS. About 140 pods handled traffic across front-end APIs, back-end services, and analytics processing. Traffic averaged around 4,000 requests per second. The front-end application called a back-end API layer, which then queried multiple downstream services. One of the most critical components was the analytics service. It powered user dashboards with aggregated data. PostgreSQL on RDS handled transactional data. ClickHouse was used for analytics queries. Redis provided caching for frequently accessed dashboard results. CI pipelines ran through GitHub Actions. Deployments were managed using Argo CD. Monitoring relied on Prometheus and Grafana. Dashboards showed aggregated service metrics, error rates, latency percentiles, and request throughput. Alerting was based on thresholds defined on those values. Initial symptoms. Users reported that dashboard pages were either extremely slow or completely failing to load. Some users saw partial data, others saw empty states. In many cases, the front end kept spinning indefinitely. From the system perspective, request success rates were still high. Most API calls returned HTTP 200. Latency averages were only slightly elevated. Nothing crossed alert thresholds, but there was one detail. P99 latency had increased significantly. Most requests were fast. A small percentage were extremely slow. Those slow requests were exactly what users experienced, but the dashboard focused on averages. And averages hid the problem. Investigation and escalation. We started by examining the front-end API service. Logs showed that requests were being processed. Some completed quickly, others took several seconds, but no clear errors. Next, we checked Redis. Cache hit rates looked normal, no obvious degradation. Then we looked at the analytics service. Query times were inconsistent. Some queries returned in milliseconds, others took several seconds. That inconsistency was suspicious. We dug deeper into ClickHouse. CPU usage was moderate, memory usage was stable, but one metric stood out. Query queue length was increasing intermittently, not constantly, just in bursts. At first, we thought it was normal fluctuation, but then we correlated it with user complaints. The spikes matched the times when dashboards failed to load. Root cause. The root cause was uneven query load distribution in the analytics layer. A recent change had introduced a new type of dashboard query. These queries were significantly more complex. They scanned larger datasets and required more computation. Because of how the query scheduler worked, these heavy queries would occasionally block other queries in the queue. When that happened, lighter queries had to wait. Most requests were still fast, but a subset of users got unlucky. Their requests landed during those blocking periods. Those requests experienced long delays. Because the majority were unaffected, average latency remained low. Error rates stayed within limits. The dashboard showed green, but user experience was inconsistent. Mitigation and recovery. The immediate fix was isolating the heavy queries. We updated the query scheduler configuration to prioritize shorter queries. We also introduced resource limits for long-running queries to prevent them from blocking the queue. We optimized the new queries by reducing scans and adding indexes. After deploying these changes, query execution became more consistent. Queue spikes disappeared. P99 latency dropped significantly. User complaints stopped. The system behavior aligned with what the dashboards should have shown. Post-mortem reflection. What actually failed was our reliance on averages. The dashboard focused on mean latency and overall error rates, but user experience is shaped by worst-case scenarios. A small percentage of slow requests can impact many users. We also lacked visibility into query queue behavior. The system appeared healthy at a high level while hiding localized bottlenecks. Our monitoring design prioritized simplicity over accuracy. That trade-off delayed detection. Engineering lessons. Averages can hide critical issues in distributed systems. Percentile-based metrics, especially P95 and P99, should be primary indicators of user experience. Monitoring should capture variability, not just central tendencies. Systems that process mixed workloads need isolation mechanisms to prevent heavy operations from affecting lighter ones. Dashboards should highlight outliers and anomalies. User experience should always be the ultimate validation of system health. That incident reminded us that a green dashboard does not mean users are having a good experience. Thank you for watching this post-mortem analysis. Always prioritize user experience over green dashboards.